Have you ever wished that you could look at your customer's car and see what was causing the problem? Well, in some cases you can, using a tool like this, a thermal imaging camera. More on that topic in today's edition of The Trainer. Today's Trainer is brought to you by Autel. For more information, visit www.autel.com. Thermal imaging, also known as thermography, is a non-contact way of seeing light that the human eye can't. It's a form of radiation that we perceive as heat and refer to as infrared, which just so happens to mean beyond red, referencing the end of the visible electromagnetic spectrum, red light. The image that we see on our thermal imaging camera, like this Autel IR100, is created by first detecting the amount of energy being emitted by the objects in the camera's viewing area. That information is then converted into relative temperature units, and that is what you see displayed on the tool screen. The image is also fully radiometric, meaning that the relative temperature of every object on the screen is being analyzed. By noting hot spots or uncommon readings, the tool helps a variety of industries perform predictive maintenance on some very expensive equipment. And the technology itself is not new. It's been in use for well over 100 years. It was first developed for military use back in World War I. You may be familiar with this use. It's called night vision, and it is still used for the same purposes by both military and first responders. It's even used in the automotive industry for pedestrian detection and other autonomous system technologies. And technicians have been using this as a diagnostic aid for over 20 years. Now, before you take it out of the box and put it to work, it's important for you to understand a few terms and some of the limitations of the tool. The first is resolution. It doesn't matter how big a screen you have on the camera. The resolution is dependent on the resolution of the sensor inside the camera. Now, the IR100 has a thermal imaging resolution of 320 by 240 pixels, and with a temperature range of -4 degrees Fahrenheit to 842 degrees Fahrenheit, the tool is more than capable of handling the automotive applications it was designed for. As a side note, the IR100 has built-in Wi-Fi that allows you to connect the camera to a mobile device, like your phone or tablet. You can control camera settings, take pictures, and even download images to the mobile device. Next is thermal emissivity. It's a measure of how well an object can give off its heat, and it's often helpful to consider that object's electrical resistance when you're trying to decide just how well it can do that. Typically, the lower the electrical resistance of the object, the better or higher an emissivity it will have. And the reverse is also true. The higher the electrical resistance might be, the lower the emissivity typically is. Again, not a hard and fast rule, but it can help you when you're adjusting your tool to take these measurements. Next is thermal reflectivity. That's the ability of an object to reflect heat from the objects around it. Now, this reflected energy is going to mask the energy being emitted from the object itself, and it's definitely going to skew your measurements. And one more factor that you may have to consider when you're using your camera is thermal transparency. That's an object's ability to allow energy to pass through it with minimal loss. Here are a few examples. A radiator hose itself is a poor emitter, but it does transfer heat from the coolant very well, so it's thermally transparent. And the dull black surface is a poor reflector, so thermal reflectivity is not a problem we need to worry about too much. Now think about that shiny AC aluminum line. It has very high emissivity, and it's very good at transferring the temperature of the refrigerant as well. But it's also highly reflective, which means that any energy that's being deflected by that shiny aluminum and hitting your camera's sensors is going to make your reading inaccurate. There is a trick though, and all it takes is a little piece of black electrical tape. You can use the tape to cover a piece of that reflective surface and get a more accurate temperature measurement. Spraying it with a dull, flat black paint will also work. Or you can adjust the camera. The IR100 allows us to correct for these factors in its menu. The higher the value, the less reflected energy is corrected for. The user can select from a preset value or set his own custom value. Now let's take a look at a few diagnostic scenarios where a thermal imaging camera can be helpful. A popular application of the thermal imaging camera is to help locate the cause of a parasitic battery drain. After all, heat is generated when current is flowing, and that's something we can see with the camera. By looking at the fuses and relays that feed the electrical systems, we can easily see one that is passing current when it shouldn't be by looking for a heat signature. Once we have the circuit identified, the camera can be used to inspect the components in that circuit. The heat radiated by one that is still on will be easy to spot. Here's a tip for making that parasitic drain even easier to find. Allow the vehicle to sit overnight so that everything on the car can reach ambient temperature. With everything else cool, that one hot spot will be much easier to see. Another common use is in diagnosing AC or cooling system issues. The thermal imager allows us to see heat flow through the radiator and condenser, as well as all the connecting lines and components that are mounted in view. Suspect a restriction or error in the heater core? Use your thermal imager to see the amount of heat going in and coming out. Do you have a customer with a consistent belt squeal complaint? Use the thermal imager to look for overheated bearings in the tensioner and or the idler assemblies. You can also see heat buildup when the belt isn't running squarely in the accessory drive, pointing to alignment issues with one of the drive's components. How about checking the heating or cooling grid so common today? Whether it's in a seat, a mirror, or it's the defrost grid on the rear glass, inspecting the operation of the grid is easy when you can see it heating up. And I'm sure you can think of many other applications for this technology. It's only limited by your own creativity. Thanks for watching, and I'll see you next time on The Trainer.